Okay, so literal equations are equations that instead of solving and just having one variable and a bunch of numbers, we are going to have a bunch of variables and we are just solving for a specific variable. So go ahead and throw your name on here. Throw your hour on here. And here are our steps. Our steps are still the same. We are going to isolate the variable we are solving for. So up until now, we've always been solving for x, so we've always got an x by itself. We've always isolated x. Today, it'll tell you what you're solving for. So on the front here, it says 4x, 4L. It says 4x a lot, actually. So we're still solving for x a lot of the time. And then when we go to solve for that variable, we are still using opposite operations. So we're solving for a specific variable, and we are still using opposite operations. What's going to be different today is that some of our problems, or actually all of our problems, are still going to have other variables in the answer. So instead of just having x equals a number, it's going to be x equals, and then there's going to be a bunch of variables within that. So, moving down, how we organize this note sheet is on the left side, we put regular equations. You want to label that? So the whole left column here, these are all regular equations. The whole right side here, this is the new thing we're doing. This is literal equations. The reason why we lined it up like this is so that you guys could see that the exact same steps you're doing with a regular equation to solve for a variable are the exact same steps you're going to do in a literal equation. So for all of these examples, there's 5 total. We'll solve the one on the left, talk about how to do that, which is something we already know how to do, and then we'll do the one on the right using the same steps. So, this first one, we've got 12 equals 2x, and we are trying to solve for x. How would we solve for x in this problem? Judah.
You would divide 2 on both sides?
Yep, we would divide both sides by 2. So divide both sides by 2. 12 divided by 2 is 6. These 2's cancel, so we just get x equals 6, which we can flip around here at the end if we want to be x equals 6 instead of 6 equals x. Okay, so if that is how we solved for x here, how we're going to solve for L over here, because it tells me I'm solving for L, is the exact same thing. So just like we got rid of 2 by dividing, we can get rid of this W by dividing. So we're going to divide both sides by W here. So we're trying to get L by itself. These W's will cancel out. So now all I have on the right side is the L. And on the left side of my equation, I leave that with the A over the W, because I can't divide A divided by W. They're not numbers that I can divide out. And just like with every equation we solved the last couple of weeks, we switched it around to be x equals at the end. We always want to switch it around to be, for solving for L, we want to switch it around to be L equals. So this will be L equals A over W. Okay, so what we've learned is the opposite of multiplication here is division. So if we need to get rid of something that's being multiplied, we divide both sides by it. Any questions so far? let's move on and look at the next one then. So the next one we've got 18 equals 5x plus 3. And we're solving that for x. And then we've got y equals mx plus b, and we're solving that for x as well. So let's start with the one with numbers. The first thing I'm going to do in an equation that looks like this is I'm going to subtract this 3. So 18 minus 3 is 15. So now I've got 15 equals 5x. And then my last step is the same. To get rid of that 5, I'm going to divide both sides by 5. (15) divided by 5 is 3. So I get 3 equals x, or I can flip that around to be x equals 3. So the reason why we're doing this extra example first is for you to see the steps. So the steps on this one were to subtract and then divide. So now, when we move to the literal equation, the steps are going to be the same. Subtract and then divide. So we are trying to get x by itself. So the first thing that we're going to do is get rid of the b. We're going to subtract the b. When we have variables, we can't actually do the math though, because we don't know what those variables are equal to. So we're going to leave this as y minus b equals mx. So we subtracted. And now we can divide. We're solving for x, which means we want to leave x behind. We want to get rid of the m. So we're going to divide both sides by m. So I get y minus b over m, I'm kind of running out of space here, equals x. And I can flip that around to x equals y minus b over m. Always flip them around at the end. Okay, any questions so far? Okay, we've got 3 more to look at. We've got 1 more on this page, and then there's 2 on the back. So the next one we've got 6x plus 2 times 8 equals 40. We put that 2 times 8 as 2 times 8 because it's b times y here. We can go ahead and multiply those out. 2 times 8 is 16. Hold on. Aiden. Alright, so our steps here, we're going to get rid of that 2 times 8, so we can subtract that 16. So we'll have 6x on the left equals 40 minus 16, which is 24. Give me a second. It's Monday. And then we can divide both sides by 6. And we will get x equals 24 divided by 6 is 4. Okay, so the steps were subtracting and then dividing. So we're going to do those same steps over here. We are trying to get x by itself, which means we need to get rid of the a and then the plus by as well. So we'll start by subtracting. So we'll subtract the by. So I'll have ax equals, right here I subtracted the by, so that's c minus by. And then to get rid of that a anytime it's just two variables next to each other, that's multiplication. Opposite of multiplication is division. So we're just going to divide here at the end. You guys will end up doing that a lot. I'm going to divide both sides by a. So I will get x equals c minus by all over a. Hey, we've got one more similar example, and then we have one like real world example on the back there that's kind of confusing, but I still want to show it to you because it's an actual real world example. So go ahead and flip this over once you are ready to move on. Check and see if I still have anyone writing. I don't think I do. Okay. So on the back here, so this next one, we've got 3 equals p minus 5 over 4. So in a problem like this, where we have a big fraction and everything's getting divided, the first thing that we need to do is get rid of what we're dividing by. So we're going to multiply by 4 on both sides here. 4 times 3 is 12. So we get 12 equals. Then over here, these 4's cancel. So I've got p minus 5. And then we are trying to solve for p, so we need to get rid of that minus 5, and we can do that by adding 5 to both sides. 12 plus 5 is 17, so I get 17 equals p. I can flip that around to p equals 17 here at the end. Okay, what was the first thing we did in this problem? Yeah, you multiply. So the first thing I'm going to need to do in this problem is also multiply. So I'm trying to solve for p once again. I'm going to multiply both sides by 4. And I'm going to end up with 4j equals p minus s. Okay, somebody else, what is the next thing we did over here? We added the 5. So in this one, we're going to add the s. So it's the same operations. That was the purpose of doing notes like this. We knew it would take a little bit longer. We wanted to show you it's the same operations. So I've got 4j plus s here equals that p. And we can always flip that around to p equals 4j plus s. Right, very last problem. Does anyone know what this last equation is? Anyone recognize it from science?
It's supposed to be like Fahrenheit.
Mm-hmm. So the F is Fahrenheit and the C would be Celsius. So it's how you convert from Celsius to Fahrenheit, and it can go both ways. So right now, this would be if we knew it was 30 degrees Celsius and we want to figure out how hot or cold it is in Fahrenheit. So for this one, the first step is a little confusing. We've got to get rid of this 5/9. 5/9 means times 5 divided by 9. So we're going to flip that, and to undo it, we're going to times 9 divided by 5. Those cancel out. So 5/9 times 9/5 cancel out. So that's the first thing that we're going to do, is multiply by 9/5 on both sides. So multiply by 9/5. I'm going to do it right here, multiply by 9/5. So 9/5 times 30, we would do 9 divided by 5 times 30 in a calculator. If I knew where a calculator was, I would do that. Nine divided by 5 times 30 is 54. So I've got 54 equals, and then this 9/5, these cancel out. So the 9 over 9 cancels and the 5 over 5 cancels. So I've got 54 equals F minus 32. Whoever's it is, turn it off. Okay. And then we've got F minus 32. To get the Fahrenheit by itself, we're just going to add 32 to both sides. So I've got 54 plus 32, which is 86, equals F. So that means 30 degrees Celsius is 86 degrees Fahrenheit. Let's check to see that that's actually true. 30 degrees Celsius to Fahrenheit is... Google's being really slow. Yeah, 30 to 86. Hey, the last one, so the last problem we have here, focus with me for like one more minute. The last problem we have here, we are again converting Celsius to Fahrenheit, but this one just gives us a general problem, and then we'll be able to plug in any Celsius temperature once we get it converted. So we still start with the first same step, which is multiplying by that 9/5. 9/5, 9/5. So it cancels over here on the right. On the left side, we just leave it as 9/5 C equals F minus 32. And then to get that Fahrenheit temperature by itself, we're going to add 32 to both sides. So 9/5 C plus 32 equals F. And we can always flip that around to F equals 9/5 C plus 32. Kind of ran out of space on that one. Okay. Any questions right now? Okay, we're going to go ahead and glue these into our notebook then. So I'm going to stop this notes video.